Let's talk briefly about inductive reasoning. We actually reason inductively all the time. Here's some examples. If in my experience all the cats I've ever seen have tails, then I might reach the conclusion that all cats have tails. Now, not necessarily true, right? But in my experience, every cat I've seen has had a tail, so that's my conclusion. Every time I eat red chili, my stomach hurts. So my conclusion is red chili makes my stomach hurt. Maybe I better think twice about eating red chili. And let's just say that I went for a drive with my mom, and yesterday and today she drove through a red light. So my conclusion is my mom doesn't believe in stopping for red lights. So inductive reasoning leads to what? Pick one. A general conclusion, a proven fact, indigestion. Well, if you said a general conclusion, you would be correct. Inductive reasoning is using your observations to come up with a general conclusion. We reason from the specific, our observations or examples, to the general. We come up with a general idea about the world around us. This general conclusion that we come up with is often called, again, you have three choices, a statement, a proven fact, a conjecture. It's called a conjecture. It's not a statement of fact, it's not a proven fact. It's an idea, it's a conclusion that I drew from observing some things. We can also call our conjecture a hypothesis. So do you remember the scientific method? We started with a hypothesis and then we tried to prove it. Getting to the point where we actually have a hypothesis that we want to test is the inductive reasoning part of the process. Again, we're observing stuff, and based on what we observe, we come up with some conclusion, and then the scientific method takes over and we try to prove it. Our courts actually use inductive reasoning. Nowadays, we take it for granted that DNA evidence is admissible in court because everybody has decided that no two people have the same fingerprints or the same DNA. Has that been scientifically proven? No. This is our conjecture. It's actually still a hypothesis, but we have so many examples, millions and millions of examples of fingerprints and DNA, and we have never found two samples of DNA that come from different people that are exactly the same. Same for the fingerprints. Let's look at inductive reasoning used in math. Most math, is looking at patterns and trying to reason out to a conclusion from the patterns. Here's an example. What's the next number in this sequence? 10, 20, 30, 40, what comes next? Well, yeah, 50. And why is this an example of inductive reasoning? Because we're looking at the details. We're observing. First we have a 10, then we have a 20, then we have a 30. We're looking for the pattern. Let's look at a little bit of number terminology. Natural numbers are numbers that we use to count with. 1, 2, 3, 4, and so on forever. Zero and negative numbers are not part of natural numbers. We could have the odd natural numbers and the even natural numbers. So now, how would we use inductive reasoning to answer this question? Is the product of two even natural numbers always even or always odd? How would we answer that question? How would we use inductive reasoning to answer that question? Well, inductive reasoning means finding a bunch of examples so we can observe. Pick out a bunch of pairs of even natural numbers, multiply them together, and see what you get. Do you always get even numbers as the answer? Do you always get odd numbers as the answer? Or is it all a mix? When we answer that question by inductive reasoning, have we proved our conclusion? No, we haven't. But the more examples we have, the more confident we are that we could have a true statement. Now, even though we have to have hundreds and hundreds and hundreds of examples to feel confident that we might have a true statement, it only takes one example or one observation to make our idea fall apart. Let's say that I've come to the conclusion that all cats have tails because all cats I've ever seen have tails. However, today I saw a cat that didn't have a tail. All right, so my whole conclusion about all cats having tails has just fallen apart because I found one example of a cat that did not have a tail. Think about these other two examples. What would a counterexample be for each of the following general conclusions? There's a lot of different answers. See if you can come up with a couple. Finally, talking about inductive reasoning, there's this thing called the Pascal's triangle, and this is a good brain exercise. It's kind of a magical triangle. I've listed here the first 5 rows, and already in the first 5 rows there are a bunch of patterns that you can see. For example, you can see down the left side and the right side there's all 1s. If you look at the second row down, 1, 1, and then you trace down the diagonal, 1, 2, 3, 4, 1, 2, 3, 4, going both to the left and to the right. And there are tons more patterns. In fact, you can find enough patterns, even just one pattern, that will allow you to write the next row, and the row after that, and the row after that. So exercise your brain a little bit. Take this triangle, see if you can list out a bunch of patterns, and there are many. And then use some of those patterns to write the next few rows of Pascal's triangle. So that's it for a little introduction to inductive reasoning. Again, inductive reasoning, you observe, you try examples, and based on your observations or examples, you come to some general conclusion, which is not a proven fact. It's something that if you wanted to, you could then go on and figure out if you could make up a scientific experiment to prove that.